Okay, we're going to show the proof for the linear systems formula. So in the other video in this playlist, there's a formula that shows you how to solve for linear systems using these variables for the coefficients and constants in each of the two linear system or linear lines. So to solve for the linear system, we built a formula. I'm going to show you how that formula was essentially built. Instead of actually putting numbers in for the coefficients of x and y and for the constants attached to those, we've given them letters. And we're going to rearrange the formula, pretty much going through the idea of substitution to isolate for x and y. So in the first equation, I'm going to isolate for x, which in the end will help us solve for our y variable. So we'll take the very first equation here, and I'm going to move ax to the other side. I have it colored to start, but from this point on, I'm going to put everything black and white just to speed it all up. Okay. So when ax goes to the other side of the equation, we essentially get negative ax is equal to by plus c. Okay, so I know there's kind of a big step there. We want to isolate for x, so we bring negative a over and we divide by it. So by plus c over negative a. Great. So we now have something that represents our value of x. So we're going to plug that into our other equation. So this now says, our equation 2, d times by plus c divided by negative a plus ey plus f is equal to 0. Okay, and I'm going to work through here. We're going to distribute our d, okay, and this becomes dby plus dc, everything divided by negative a, and then plus ey plus f is equal to 0. Now I want to get rid of this fraction of negative a, so I'm going to multiply the entire equation by negative a. And when we do that to the first part, when we multiply by negative a, these two created 1, and then we're going to have to multiply this by negative a, and this by negative a, and even the 0 by negative a. So what ends up happening there is those cancel out, and we're left with dby plus dc. This becomes minus aey. This becomes minus af, and 0 times a is, or times negative a is still 0. Okay, so now that we've done that, we're going to get our coefficients and variables together. So here are our variables with their coefficients, and we want our constants together. So we're going to move all the constants to one side. So our dc and our af, there's no x or y variable attached to them, so we're going to move them to the other side of the equation. When we do that, we're left with dby minus aey is equal to, and what will happen is we'll get af will be positive on the other side, and dc, so d times c, will be negative. Now here what we're going to do is something called common factoring. So we're going to common factor the y value out of this. So it will become y outside the brackets, and we'll have db minus ae, okay, is equal to af minus dc. And in order to isolate for y, because this is y times this bracket, we'll have to bring this entire bracket to the other side, and when we do that, it'll become division. So this will become like one large fraction over the other. And we'll get y is equal to af minus dc over db minus ae. And you can switch around whether the f and the a are first, the d or the c are first. All of that works out fine as long as we have our beside each other because of a multiplication rule. So that isolates for y. Let's do the same thing for x. So I'm going to take our first equation again, and I'm going to isolate for y this time. So this time it'll be negative by is equal to ax plus c. Same idea, y will be equal to ax plus c divided by negative b. So now we're going to take this y value, and we're going to plug that into the y in the other equation. So bear with me, you won't be able to see the whole thing in one shot here. But our equation 2 was dx plus e, and e was times y, so here's our y, ax plus c over negative b plus f equals 0. We're going to try to work on the left side here. I'll kind of draw a line here, help us out. Okay. Like we did before, I'm going to have to distribute the c, and I'll go through this part a little quicker now because you've seen how this distribution works. Dx plus eax plus EC, all of that is divided by negative B, plus F equals 0. I'm going to multiply everything by negative B, as you saw before, and that will end up with negative B dx. The negative B will just cancel out on these ones, and we'll get plus EAX plus EC minus BF equals 0. Again, we'll keep our variables on the left side, and we're going to move our constant terms to the right. Okay, and this will end up being, I'm just going to rearrange them, so EAX minus B dx is equal to, and this will become BF, will become positive, and EC will become negative. Same idea, we're going to common factor out this x, so it'll become x bracket EA minus BD is equal to BF minus EC. And again, we bring over the entire bracket, so it becomes like a large fraction. X is equal to BF minus EC divided by EA minus BD. And there you have it. That's how those two formulas at the bottom, we'll kind of highlight them. Here's our F formula, and here's our X formula. That's how those two formulas are built, assuming we start up and our equation this way, our linear system.